Morning sir, I am N.Navitha from CSCD section. My topic is about queue operations. Introduction to queues. A queue is a linear data structure that follows the first in first out principle. In a queue, the first element added is the first one to be removed. Queues are commonly used in scenarios like scheduling tasks, managing resources and handling requests. The primary operations in a queue are enqueue and dequeue and peak. Each operation serves a distinct purpose in managing the elements of the queue. Understanding these operations is crucial for implementing queues effectively. Enqueue operation. Enqueue is the operation of adding an element to the back of the queue. For example, if we enqueue the numbers 1, 2 and 3, the queue will be represented as this. This operation typically has a time complexity of 01, making it efficient. Algorithm void insert int value. Step 1, start. If rear equals to size minus 1, then display queue is full. Else, if front equals to minus 1, then front equals to 0. Rear plus queue of rear equals to value. Display insertion success. Then stop. Dequeue operation. Dequeue is the operation of removing the front element from the queue. For instance, if we dequeue from the queue of 1, 2, 3, the returned value will be 1 and the new queue will be 2, 3. Like the enqueue operation, dequeue operation also has a time complexity of 1. Dequeue is the operation of removing the front element from the queue. For instance, if we dequeue from the queue of 1, 2, 3, the returned value will be 1 and the new queue will be 2 and 3. Like the enqueue operation, dequeue also has time complexity of 1. Algorithm for the dequeue. First, void delete. Start. If front equals to minus 1, then front less than rear, then display queue is empty. If else, display deleted. Queue of front. If front equals to rear, then front equals to rear equals to minus 1. Front plus, then stop. Peak operation. Peak allows us to view the front element of the queue without removing it. For example, peaking at the queue 2, 3 will return the value 2. This operation is useful for checking the next element to be processed without alternating the queue. Peak allows us to view the front element of the queue without removing it. It means without removing the element, we displays the value of the front element. For example, peaking at the queue 2, 3 will return the value 2. If we peaking at the queue of 2, 3, then the value of front is 2, right? Then it return 2. This operation is useful for checking the next element to be processed without alternating the queue. Display or traverse. Display operation used to visit all elements in the queue. Algorithm for this: void display. Start. If rear equals to minus 1, then display queue is empty. Else, display queue elements are we take for loop, and in that I equals to front, I greater than or equals to rear, I plus. Display queue of I. Stop. Queue implementation using arrays. A queue can be implemented using a fixed size array to store its elements. In this implementation, We track the front and rear indices to manage NQ and DQ operations. However, a fixed size array can lead to overflow if not handled correctly. A queue can be implemented using a fixed size array to store its elements. In this implementation, we track the front and rear indices to manage NQ and DQ operations. However, a fixed size array can lead to overflow if not handled correctly. Queue implementation using linked lists. A linked list can be used to implement a dynamic queue that grows and shrinks as needed. Each element in the queue is represented as a node in the linked list with pointers to the next node. The implementation allows the efficient memory utilization without the risk of overflow. A linked list can be used to implement a dynamic queue that grows and shrinks as needed. Each element in the queue is represented as a node in the linked list with pointers to the next node. This implementation allows for a efficient memory utilization without the risk of overflow. Applications of queue. Queues are widely used in computer science for scheduling processes in operating systems. They are also utilized in breadth first search algorithms for traversing graphs and trees. Additionally, queues effectively manages tasks in asynchronous programming and handling requests in web services. Thank you.